Hi everyone, welcome to my YouTube channel. In today's lecture, we will see some numericals on torsion. Before that, what we have learned in a previous video, that is, it's all related to the torsion. Clear? So first we have seen what is shaft. Shaft is nothing but it's an cylindrical element or machine element which is used to transmit the power. So in that, shaft can be transmit motion along with the torque, and we have already learned the formula for power also, that is 2 pi nt divided by 60. And then we have seen this formula which is having the relation between the shear stress divided by radius of shaft and c theta divided by L q by r. And second most important relation is torque transmitted or maximum torque transmitted by shaft, that will be equal to pi by 16 into tau into d cube. So this is another one. So if you consider the hollow shaft, then pi by 16 into tau into d outer diameter raised to 4 minus inner diameter raised to 4 divided by outer diameter. Now why we prepared hollow shaft, why we not use solid shaft? Today we will see that thing, and then we learn the power, that is 2 pi nt divided by 60. Then we learn this expression which is having relation between the t by j, that is equal to c theta divided by L, that is again equal to tau by r. So this is another important result. And then we learn polar moment, that is Zp, that is equal to the j divided by r, that is ratio of polar moment of inertia to the radius of shaft. Then we evaluate Zp value for hollow shaft and solid shaft. Then we learn the strength of shaft or torsional rigidity. It is just a multiplication of modulus of rigidity and the polar moment of inertia. So today we will see some numerical based on the torsion and how the hollow shaft is prepared than the solid shaft. So first I will I will start with the simple numerical. So I will write over here given data. Now shearing stress of the solid shaft should not exceed. So what is given? Tau is given. Shearing stress is given, that is 40 Newton per mm square. When the torque transmitted is this one. Now here we always consider maximum torque. As nothing is given, I will consider this as a maximum torque, that is 20,000 Newton meter. So as this is in mm, I will convert 20,000 into 10 raised to 3 Newton mm. Now they are asking about the minimum diameter of the shaft. The shaft which can transmit this much amount of torque, we need to find out the diameter of the shaft. So we have a direct standard relation, that is torque equal to pi by 16 into tau into d cube. So we will just put all the given data, that is tau is 20 into 10 raised to 6. I will consider this 3 and this 10 raised to 3, 10 raised to 6 into, now diameter we need to find. Clear? So I will consider d cube, but torque value is given, so I will write that torque value. So sorry, so it's not a torque value. Here we need to consider the shear stress. So shear stress is 40. Clear? And torque is given 20,000 into 10 raised to 3. So only unknown is d. If you evaluate for that d, then it will become 136.2 mm. Clear? So it is 137 mm. Clear? So this was a simple formula. From that we can evaluate the diameter of shaft. Now same thing, same numerical can be asked for the hollow shaft. In that case we must determine the outer diameter and inner diameter of the hollow shaft. Clear? So expression that is for hollow shaft, it becomes torque equal to pi by 16 into tau into d raised to, so here we need to change the formula as we are evaluating for the hollow shaft. Here we need to use same formula, that is d raised to 4 minus di raised to 4 divided by do. So remaining thing it will remain same. So d raised to 4 di raised to 4 divided by do. So if in exam if it is asked for the hollow shaft, then we use this expression. Now remember, always consider this torque as a maximum torque. Here also we have considered this torque as a maximum torque. Clear? Now we need to see some numericals which is based on the hollow shaft and the solid shaft. Clear? uh, a solid cylindrical shaft, both are the same. Now here I will consider this one numerical. So previous is also a similar one, this one and this one. A small changes are there, we will see that small changes and then we will solve these numericals. Okay, now here I will write a solid cylindrical shaft can transmit power. Now here power is equal to 300 kilowatt and speed is 100 rpm. Clear? Now shear stress, that is tau, it is not exceeding the 80 Newton per mm square. Now what is asked, what percentage saving in weight would be obtained if this shaft or same shaft is replaced. Now what is happening here, we are going to replace the solid shaft with the hollow shaft. So when we consider the hollow shaft, then there will be a two diameter, that is internal diameter and external diameter. Clear? Now we will see here relation is given, that is shaft is replaced with the hollow one with the internal diameter equals to 0.6 of outer diameter. So I will write that expression di equal to 0.6 do. Now here if you consider the length material and maximum stress shear stress being same, so for both the cases if you observe it is same for hollow shaft as well as solid shaft. Now I will write, first I will evaluate the torque. Clear? Now for that I will write power is equal to 2 pi nt divided by 60. Now power value is given 300 into 10 to the 3 into 2 pi n is given 100. Torque we need to evaluate divided by 60. So if I calculate the torque, then it will become 2 phi n divided by 60 into 300 into 10 raised to 3. So this value will become 28647.88. So this is in Newton meter. So always remember, whatever we evaluate the value for the torque, it will be in Newton meter. Now this we need to consider in Newton mm, as we are considering all other value in mm. So I will write 28647.88 into 10 raised to 3, that will be Newton mm. Clear? Now what we will do, we will evaluate solid shaft diameter, and then we will evaluate the hollow shaft diameter. Clear? So for solid shaft, as we already use this equation, we will repeat the equation, that is T equal to pi by 16 into tau into d cube. So tau is 28647.88 into 10 raised to 3, that is equal to pi by 16 into tau. Value of tau is given 80. So here I will write 80 into d cube. So for d cube I will write 28647.88 into 10 raised to 3 into 16. Now this pi and 80 will get divided over there. So 28647.88 into 10 raised to 3 into 16 divided by pi into 80. So if you take cube root of value, then I will get diameter D equal to 122.17 mm. So this will be the value for diameter. Clear? Now next, so this is the diameter of solid shaft. Clear? Now we need to evaluate diameter of hollow shaft. Clear? Now for that purpose I will use equation pi by 16 into tau into outer diameter raised to 4 minus di raised to 4 divided by d. Clear? So this is an expression. So here if you observe this one, in last video we seen the torque transmitted by hollow shaft, that is torque is equal to pi by 16 into tau into outer diameter raised to 4 minus inner diameter raised to 4 divided by outer diameter. Clear? So we will use the same. Now torque transmitted, it is same. So here it is written maximum shear stress is also same, and for that capacity we need to evaluate the diameter. Clear? Now here if you observe, we have another relation, that is inner diameter equal to 0.6 outer diameter. Clear? So I will put all the information over here. Pi by 16 into tau into, so here instead of tau I will write 80 here I will write 80 and do raised to 4 minus instead of di, so this is also do. Instead of di, I will write 0.6 do raised to 4 divided by do. Clear? So the torque is again same, that is 28647.88 into 10 raised to 3. Clear? So I will just simplify this equation. So here we need to consider 0.6 raised to 4, then 1 minus answer, so 544, so it will equal to 544 divided by 625 into do cube. Now why cube? This do and this will get cancelled. I just make it simple. I have made just simple. Clear? Now I want the value of do. Clear? So I will just transfer all the terms over there, then 28647.88 into 16 into 625 divided by pi into 80 into 544. Clear? And if I take cube root of answer, then I will get outer diameter equal to 128 mm. Clear? So here you will get 128 mm. Now we have relation between the inner diameter also. Clear? Inner diameter is equal to 0.6 into outer diameter. So what will be the inner diameter into 0.6? So that will be the 76.80 mm. Clear? So it is near about 77 mm. So now we have the inner diameter and outer diameter for hollow shaft. So these are the values for hollow shaft, and this one, this was the diameter for solid shaft. When the material is same, torque transmitted is same, shear is also same, then modulus of length of the shaft is also same. Clear? Now here I will consider the weight of the solid shaft. So weight of the solid shaft, then I can write weight density into area of solid shaft into length. So if you observe the density, mass divided by volume. So instead of density, here instead of mass I am taking the weight. So if you write for weight density, it will be equal to weight divided by volume. Instead of volume I am writing area and length. So if you want to evaluate the weight, then I must multiply this weight density into a area into length. Clear? I am doing the same thing. So weight density, I will write W for the solid shaft into, so weight density will be there, weight density into area of solid shaft is pi by 4 d square into L. Now same thing similarly for weight density of hollow shaft. So that will be again equal to the weight density into area of hollow shaft. So that will be equal to pi by 4 do square minus di square. That is outer diameter into inner diameter into length. Clear? Now we will see percent saving in weight. Clear? Now percent saving in weight if you use a hollow shaft, then I will write weight of solid shaft minus weight of hollow shaft divided by weight of solid shaft into 100. So if you observe, so if I write, then weight into pi by 4 capital D square into L minus W into pi by 4 outer diameter square minus inner diameter square into L divided by W into pi by 4 into D square, clear, and into 100. Simple. So if I take common W, L and pi by 4 from this equation, then so this W and pi by 4 it will get cancelled. So I can write D square minus DO square minus DI square divided by D square into 100. By putting all the information, that is D value is 122 square minus outer diameter is 128 square, inner diameter is 77 square divided by 122 square. So here I will get 29.55%. so that is the percentage saving in weight. Clear. So yesterday I have not discussed why we prefer the hollow shaft instead of solid shaft. So if you observe, we have derived both the cases, solid shaft and equation for hollow shaft. Now from this equation, why I am taking this one, because this is the most important thing. Here if you observe, if you use a hollow shaft, if you use hollow shaft instead of solid, then we can say that there will be a near about 30% saving of weight will be there. Clear. So always we prepare a solid, sorry, hollow shaft instead of solid shaft for the transmitting the torque. Clear. I hope you understood the entire equation. Clear. Now let's move to the next numerical. Now this is based on the weight. Is it same? No, it is not same. Okay, so here we'll consider 1 and 2, again 2. Okay, so a hollow shaft which is used to transmit the power equal to 300. So I will write given data power 300 into 10 to the 3 in watt. Clear. N is given 80 rpm. If the shear stress is not exceed tau, is given 60 Newton per mm square. Internal diameter, that is di, equal to 0.6 outer diameter. Find the external and internal diameter. So what we need to evaluate, internal diameter and external diameter, assuming that the maximum torque, now here maximum torque, so T max is equal to 1.4 T min. So this is very important point for the discussion. Now if you observe the formula for power, that is 2 pi nt divided by 60. So from this formula, if you observe, so yesterday also I have discussed, so this T, So this T is nothing but it's a mean torque, and it is in Newton meter if power in watt and in RPM. Clear? So remember this, from the power formula we get the mean torque. Clear? So I will put all the value. Power equal to 300 into 10 raised to 3 into 2 pi n is 80 rpm, and torque we need to find. So this will be the mean torque divided by 60. So from this equation we can evaluate mean torque. So it is 300 into 10 raised to 3 into 60 divided by 2 into pi into 80. So we get the torque, mean torque, equal to 35809.86 Newton meter. Remember, so whatever this value it will come, it will be in Newton meter, not Newton mm. Clear? Now, so if you evaluate based on this torque, then definitely whatever the shaft will be there, it may be get fail. Why? Because the diameter which we are going to evaluate from this formula for hollow shaft. So here what we derived, so this is derivation for torque transmitted by hollow shaft, or we can say maximum torque transmitted by hollow shaft. Clear? So that's why first I would like to evaluate the maximum torque, so that is equal to 1.4 into T mean. So if I multiply by with 1.4, then I will get torque, maximum torque, that will be equal to 50133.80 Newton meter. And if you want in mm, then 50133.80 into 10 raised to 3 Newton mm. Clear? Now here I will consider the formula for torque or maximum torque transmitted by hollow shaft, that is pi by 16 into tau into same formula we are using. Clear? Now here I will put the value of maximum torque, that is 50133.80 into 10 raised to 3 equal to pi by 16 into tau. Now here instead of di, what is the relation given? 0.6. So in bracket 0.6 do raised to 4 divided by do. Clear? So if you just simplify this, then we get the entire equation in terms of do. So that do will be equal to 533.80 into 10 raised to 6 multiplied by 16. So here I am considering 16, then divided by pi. Clear? So into 16 into, so 87.4. So if you take cube root of this, then outer diameter it will be 169.2 mm. Clear? So it is near about 170 mm. Now what is internal diameter? That is di will be equal to 0.6 into do. So 0.6 into 170. So this is 0.6 into 170. It is 102 mm. Clear? So this is a simple numerical, but the twist is in power formula. Remember, this T is nothing but T min, and we need to evaluate the maximum torque. Clear? I hope you understand this also. Okay, now we will see some numerical based on the relation between the torque, then shear stress, then modulus of rigidity, angle of twist, that is theta, Clear? Now in this problem statement, if you read the problem statement, then we get determine the diameter of solid shaft. So we need to evaluate the diameter of solid shaft which transmit power, that is 90 kilowatt. So that is 90 into 10 raised to 3 watt. Clear? N is 160 rpm. I'll determine the length of shaft. If now here again we need to evaluate the length of shaft also. When theta is given 1 degree, we need to convert into radian. So it will be pi by 180 radian. Clear? Now the maximum shear stress, that is tau, it will be equal to 60 newton per mm square, and modulus of rigidity, that is C or G, that is equal to 8 into 10 raised to 4 newton per mm square. Clear? Now as the power is given, speed is given, we can evaluate the torque. So first we evaluate the torque. So P is equal to 2 pi nt divided by 60. So power is 90 into 10 raised to 3 equal to 2 pi into n is 160 into torque divided by 60. So value for the torque is 90 into 10 raised to 3 into 60 divided by 2 into pi into 160. Clear? So torque will be 5371.47 Newton meter, and if you want to convert in mm, then 5371.47 into 10 raised to 3 Newton mm. Clear? Now as we know the torque, then we can evaluate the diameter. So from the first numerical you may observe that is pi by 16 tau into dq. So torque is 5371.47 into 10 raised to 3 equal to pi by 16 into tau. The value of tau is 60 into d cube. So if you evaluate for the diameter, then it will be equal to 5371.47 into 10 raised to 3 into 16 divided by pi into 60. If you take cube root, then we get diameter equal to 76.96. So it is near about 77 mm. So here from this equation we can get the diameter value 77. Then how to evaluate the length? Then we must use the relation, that is tau by r equal to g theta by l. So that expression I will show you in last video. We see tau by j is equal to c theta divided by l is equal to tau by r. Clear? Now we will use the same value of tau is given. How much? It's a 60 divided by 2. If you take, then it is radius is 38.48. Value of g or value of c, it is given 8 into 10 raised to 4. Am I right? Yes, 8 into 10 raised to 4 into theta, it is given in degree, but we need to consider in the radian mode, as our calc is in radian, and put your calcs also. So from this we can evaluate the length, that will be equal to 893.6 mm. Clear? So this was a very simple numericals you must understand. Now let's see the next numerical. Determine the diameter of shaft. So we need to evaluate the diameter of solid shaft, which will transmit. Again, power is given 300 kilowatt and speed is given 250 rpm. Maximum shear stress, that is tau, is given 30 newton per mm square, and twist or theta is given 1 degree, that is pi by 180 radian. And now here length is given 2 meter and modulus of rigidity C or G is given 1 into 10 raised to 4 newton per mm square. Now we will use one expression that we have derived, that is T by J is equal to C theta by L is equal to tau by R. Clear? Now if you observe this, from this R we can get the diameter. Clear? Now we can use this expression or we can use this expression. Clear? So we will see one by one, or we can use our first equation also, that is we have seen earlier, that is tau is equal to pi by 16 into tau into d cube. Now we have not evaluated torque, so first we will see power is equal to 2 pi nt divided by 60. So power is 300 into 10 raised to 3. Consider always in watt, into 2 pi n is given, that is 250 into torque divided by 60. So 300 into 10 raised to 3 into 60 divided by 2 into pi into 250. So the value of torque will be 11459 into 159 Newton meter. Here while considering, I will consider in mm, Newton mm. So I will write 11459.1559 into 10 raised to 3 equal to pi by 16 into tau. Value of tau is 30 into d cube. Only unknown is d. So if you evaluate for this d, then it will be 124.5 mm. So it is near about 125 mm. Okay, so from this we have evaluated the diameter. Clear? Now again we can evaluate based on angle of twist also. So that is T by J equal to C theta divided by L. Now value of J, that is nothing but pi by 32 d raised to 4. Clear? So this we have seen earlier. This is the polar moment of inertia along ZZ direction, or that polar moment of inertia along the perpendicular direction. Clear? So if you put this value over here on this equation, then this equation will become, so value for the torque is 11459.1559 into 10 raised to 3 divided by pi by 32 into d raised to 4 equal to, value for C is 1 into 10 raised to 4. Am I right? Yes, 1 into 10 raised to 4 into theta is equal to pi by 180, and length is given 2 meter. So again I will consider in mm, 2 into 10 raised to 3. So in this expression, if you observe, only unknown is a diameter. Clear? So if you solve this equation, then it is near about 107.5 mm. The diameter will be 108 mm. Now From both the equation we got the different diameter. Clear? So here we got 125 mm, here we got 108 mm. It is always better to have a larger diameter. If you take this, then it might be get fail. So consider larger value of diameter. Clear? Then answer must be diameter of shaft will be equal to 125 mm. Clear? You may consider this equation also, d theta divided by L into tau by R. Then also you will get the same result. You can evaluate the diameter, check this diameter. Always consider the maximum diameter only. Clear? So whenever the numerical asked based on the diameter, then we must consider the larger. I hope you understand the all numerical. So here I will just explain you what are the changes or what is this numerical set. I have just kept aside as a time being, so I will just explain you how to solve this equation. Now circular shaft is given along with hollow shaft whose inside diameter is di is 3/4 of do. Clear? Having same material means modulus of rigidity will be same, equal length and required to transmit the given torque. So torque is also same. Compare the weights of the shaft. If the maximum shear stress developed between the two shafts is also same. Now here if you observe, the maximum shear stress is same, torque transmission is same, material is same, length is same. Clear? Now we have solved this equation, so this one. Similarly we will solve the same numerical. Clear? So first I will consider for solid shaft, that will be the pi by 16 into tau into d raised to 3. Clear? So here torque will be same, so I will consider this equation as 1. Again for hollow shaft, then torque equal to pi by 16 into tau into do raised to 4 minus di raised to 4 divided by do. Clear? So instead of di I will write 3/4 time of do. So pi by 16 into tau into do raised to 4 into 3 by 4 do raised to 4 divided by do. Clear? If you solve this, then I will get pi by 16 into tau into do raised to 4 into here 3 raised to 4, it is equal to 81 sorry, and 4 raised to 4, it is 256 do raised to 4 divided by do. So here we must consider, and if you simplify this equation, then torque transmitted for hollow shaft, it will be equal to pi by 16 into tau into do cube into 0.6836. So here we get two equation. Clear? Now if you observe the torque transmitted here, what they are giving for the given torque. Clear? So if you consider the for given torque, we must consider the same torque. Clear? So if you compare this equation from equation 1 and 2, I would like to write as this t and this t is same, so I will equate both the equation. Then pi by 16 into tau into capital D cube equal to pi by 16 into tau into outer diameter cube into 0.6836. Now this diameter is different and this one is different. This is for solid shaft, this is for hollow shaft, but we can have a expression. So this pi by 16 and tau, it will get cancelled, so d cube it will be equal to 0.6836 into outer diameter of the hollow shaft. Clear? Now we need to consider the weight. Clear? So this is cube. Clear? So what we required, we need to evaluate this all for the weight expression, which we have already seen in previous numerical. Clear? So what I will do, I will take cube root of all. So if you take cube root, then I will get expression 0.8809 into do. Clear? So as we have seen the weight equation, so here weight density into area into length. Clear? So for solid shaft I will write weight for solid, here I would write weight density into area into L, so W into pi by 4 d square into L. So for hollow shaft I will write W into A into L equal to W into pi by 4 do square minus di square into L. So instead of di I will write for do, so W into pi by 4 do square minus, I think it's 3 by 4 do whole square. Clear? So into L, if you simplify this again, okay, 3 square divided by 4 square, it is 9 by 6, 1 minus answer, then I can write W into pi by 4 into 7 by 16 d square into L. Clear? Now what they are asking, they are asking about the ratio, so Ws divided by Wh, so it will be equal to W into pi by 4. So from this equation 4 and from equation 5 I am writing pi by 4 into d square into L divided by W into pi by 4 into 716 do square into L. L will get cancelled, pi by 4 will get cancelled, W into W it will get also cancelled. Now I have equation, that is d equal to 0.8809 do. So I will write in that expression, that is 0.8809 into do. So this is in whole square divided by 7 by 16 do square. So this do and this do it will get cancelled, then I will get the ratio of solid shaft to the hollow shaft, that will be 1.77. Clear? So if you observe the weight of solid shaft, it is 1.77 of the hollow shaft. So from this equation also I can say that weight of solid shaft is in larger side compared to the hollow shaft. So to transmit the torque we prepared the hollow shaft. Why? Because weight of the hollow shaft it will be less to transmit the same amount of torque. I hope you like this video. If you like this video, then you can share and subscribe the channel. Thank you.